If you look at the top of 9.1, first off, we're going into Chapter 9. We're not skipping Chapter 8. It's just Chapter 8 comes with a short project. I'll give you this is what it'll end up looking like, and we'll talk about it when we get there. But Chapter 8 comes with a project that we do right before spring break. So it's like no content. We just do this project and then go into spring break. So in order to do that, we need to do Chapter 9 first, and then we'll go into Chapter 8. Chapter 9 is about triangles, right triangles to be specific, and the very foundation of it is the Pythagorean Theorem. You will have questions about Pythagoras, which is who is on your page. There's a big blank section. You will, write down what you deem important from the board. So Pythagoras was his name. He is the father of numbers. So he's a Greek mathematician known for his contributions in religion and science. So in Greece, a very long time ago, there were groups of smart men. You had Plato, you had Socrates, you had Aristotle, Archimedes, Pythagoras. Some were more philosophers, and then some were like math people, like our guy here, Pythagoras. He's very weird. I'm going to tell you how weird he was. I'm going to tell you all the things that I know about him. It says religion, but you and I would call it a cult. Like he was a leader of a cult. Very interesting. And then he had just the one accomplishment that we have documented. They say in science, your textbooks will say, but it's in math. So obviously his name's Pythagoras. So he discovered, I would put in quotation marks, he discovered the Pythagorean Theorem, a way to solve for a missing side in a right triangle. So he discovered the Pythagorean Theorem, a way to solve for a missing side in a right triangle. So he discovered the Pythagorean Theorem much like Christopher Columbus discovered America. Okay, America was already here. Christopher Columbus came over here and was like, look at this new place. I'm going to name it what I want to name it. Just like Pythagoras came upon this theorem and he named it after himself. But they actually used the Pythagorean Theorem to build the pyramids back in the day. So it's been around for a very long time. Everything that I tell you is from a textbook. I tell you this because students have questions every year about the certain things that he made up. I am taking everything from a book, and I'll show you. So like the first thing, in his cult, or in his religion, if you will, new initiates had to stay silent for 5 years. That was their first requirement. They're just in there. That was their first requirement, and people ask me, did they have to stay silent in their own house? Did they have to? But why? I don't know all the answers. My guess as to why, whenever you have to be silent and you can't talk, you can't be on your phone or can't watch TV or you have nothing to do, what do you normally do with your life while you sit there silently? You sleep. What else? Okay, read. What else? Look for something specifically. You do sleep, you do read. There's one more. Don't overthink it. Well, if you're silent, though. Kind of, but in your head. It's called thinking. We think. We just sit and think. Do we not? Think about our day. Think about our life. Think about things that have happened. Just think. Okay? So the purpose of this is if you are silent, then you can reach a deeper level of thinking. You can gain intelligence. You can think of questions to ask and things to explore. So that was that. He was vegetarian because he didn't want dead carcass in his soul. So he had a lot of like the reincarnation thoughts. Like if you die, you become an animal, things like that. So he didn't like eating animals. And if you were a part of his following, you did not eat animals, you were vegetarian. He and his followers prayed to the divine number 10. The number 10? I don't know how. I don't know how you do that. But the divine number 10. I did not say, let me throw in the word divine here. This was literally from a text, like from a textbook. Divine number 10. I don't know how. I don't know why the number 10. I think there are better numbers out there, but number 10. Their symbol, so like think of like a logo, like the Nike check kind of thing. This school has a logo. The logo of theirs, the sacred symbol, they called it a tetractys. It looks like this. It's got 10 dots and then some triangles in it because triangles are also a sacred shape. Okay, but more importantly about this guy is that he had a weird belief of numbers. Like you and I, when you think of numbers, we know there's like negative numbers, right? And then there's positive numbers. What are the numbers between numbers? So like what numbers are between 0 and 1? Which one? What numbers are between 0 and 1? Fractions, like 1/2, 1/3, 1/4, all that, right? He did not believe in irrational numbers. So one day, a man argued with him and told him that they existed and gave him proof of it. And Pythagoras did not like that, so he slit his throat. And then that was the end of that conversation. So there are many texts that say he killed a man for discovering an irrational number. Because being back in the day in Greece, like you wanted to be the smartest man in the room. So when someone is contesting that, it's, I guess, something to die over. The way he died is very interesting. He and his followers were having a meeting, and the people that weren't in his group but wanted to be in, maybe they were and they got exiled. Maybe they never made it the cut with the 5 years because that's a really long time in your life. But nonetheless, they knew he was at this meeting, so they set the building on fire. Pythagoras fled. He ran. He came upon a field of beans, and for some reason, either he was scared of them or he found them to be sacred too. Who knows? He would not walk through the field of beans. He tried walking around. So the mob found him, and instead of just going through the field of beans, he said, I would rather die of slaughter than run on beans. And so he did. And that's how his story ends. Weird guy. So a lot of people ask, Ms. Marshall, how did they catch up to him? Like, if I flee a building, you're not going to find me. I just want to show you his age. So I know that it looks like he's super old. However, BC, they count down. So to count from 570 to 500, that's 70 years, and then from 500 to 495 is 5 years. He was 75 years old. So when he runs from the building that's on fire, he's not running fast. So that's how he dies. That's it. That's our guy. He discovered the Pythagorean Theorem. You can actually find tablets with the Pythagorean Theorem used to build the pyramids, like I said, but also dating back to like Babylonian times, like the Tower of Babel. So we'll talk about what that looked like in a second. But 9.1, Pythagorean Theorem, that was our guy, Pythagoras, who named it. Let's talk about what it looks like. Your textbook is going to say c squared equals a squared plus b squared, but all of your life you've seen a squared plus b squared equals c squared. So this is what we're going to use. You'll see a box in the middle. It says the Pythagorean Theorem. A squared plus b squared equals c squared. All right, and what matters is c squared always has to be the hypotenuse. Always. So the hypotenuse is always the longest side, and it's always across from the right angle. Okay, here's why. If you remember in chapter 6, sides and angles that are across from each other, they coordinate. So this 90-degree angle is the biggest angle in the triangle, so this is the longest side. Okay, so that is what we're going to plug in. The other A and B will always be the legs, so the non-hypotenuses. This just shows you what a Pythagorean theorem looks like with the squares. Give it a second. I used to have students, I would bring in Cheez-Its, and you would line up Cheez-Its to show a right triangle. But, the funds are low and the corona, we're just not doing it this year. But, just to show you, What is the length of side A? It is 3. There's 1, 2, 3, right? What is the length of side B? 1, 2, 3, 4. And then the length of side C is 5. 1, 2, 3, 4, 5. What's 3 squared? 9. You'll want your calculators. 4 squared? 16. 5 squared? 25. So this Pythagorean theorem says that a squared plus b squared equals c squared. What is a squared plus b squared? What's 9 plus 16? 25. Does 25 equal 25? So that is how we have a right triangle. So what they would do back in the day, obviously they didn't have A, B, and C when they built the pyramids. The English language, probably not a thing. Don't know what they had, but what they do was they would have perfect squares, and then they would line them up to make a right angle. Okay? So we are going to look at one more thing and then start some math. This is called a Pythagorean triple. I want you to write down that word, Pythagorean triple. You can write wherever you choose on this paper. Pythagorean triple. And I'll tell you what it is. We're going to do math right there. Pythagorean triple. So Pythagorean triple are 3 whole numbers. Whole, W-H-O-L-E. 3 whole numbers that satisfy a squared plus b squared equals c squared. So 3 whole numbers, W-H-O-L-E, that satisfy a squared plus b squared equals c squared. So 3 whole numbers that satisfy a squared plus b squared equals c squared. I'll show you what it looks like. Your textbook actually has lists of the Pythagorean triples. You don't have to memorize them. But what is interesting, my husband used to build houses when we lived in New York, and builders actually memorize Pythagorean triples because you use them every day. So here's what that would look like. Everything needs to be a right angle. The floors need to be a right angle. The walls need to be a right angle. Doorways need to be a right angle. So here's what would happen for them to check their work. They measure like the length, the width, and a diagonal and see if it is a Pythagorean triple. Okay? Because if it were, then that means you would have a square, we call it square, a square door, like a right angle in your doorway. What you want to know is that the most common Pythagorean triple is 3, 4, and 5. So the most common Pythagorean triple is 3, 4, and 5. It is a question on your test. You're going to see it a lot next week when we go into 9.2, 4, and 5. So the most common Pythagorean triple is 3 squared plus 4 squared equals 5 squared. 3, 4, 5. The most common Pythagorean triple is 3, 4, 5. All right, so we're going to use the Pythagorean theorem here in these examples. Find the value of x, then tell whether the side lengths form a Pythagorean triple. So we have 2 sides in a right triangle. We need to find the third. We're going to use the Pythagorean theorem. A squared plus b squared equals c squared. All right, what is the hypotenuse? What is the longest side here? It's going to be x. So I just plug in x where c was. For B, A and B, it doesn't matter which one you label A and B as long as they're the legs, so the non-right or the non-hypotenuses. So 81 and 108. This is why you want a calculator, because nobody wants to be doing 81 times 81. In a basic calculator, yeah, that stinks for you. In a basic calculator, you want to do 81 times 81. Why isn't it working? This is working right there. $6,561, and then what is 108 squared? 11,000 what? 664. And then this dropped down the x squared. We didn't do anything with it. Combine like terms, or just add the two on the left. 6,561 plus 11,664 is 18,225. All right, and then the last step. So I guess I'll just say it. Yeah. So x is being squared. You need to do the opposite. So the opposite of squaring is a square root on both sides. So you want the square root of 18,225, which is 135. Before I circle this, I need to determine whether I have a Pythagorean triple. Are all three of my side lengths whole numbers? Yes, 81, 108, and 135. So you're also going to write yes, because it asked, is it a Pythagorean triple? And yes, it is. All right, let's do number 2. Again, we have two sides in a right triangle. We need to find a third. We're going to use the Pythagorean theorem. A squared plus b squared equals c squared. All right, what is the hypotenuse here? What's the hypotenuse? Tryon? It's 8. It's across from the right angle. It's going to be 8. All right, and then A and B are the legs, the ones that are attached to the right angle. So x and 4. Drop down my x squared. What is 4 squared? 4 times 4. 16. And then 8 times 8. 64. Subtract 16. 64 minus 16 is? It is 48. So again, x squared equals 48. We want to get x by itself. X is being squared. The opposite of squaring is square root. So x equals, we're going to round to the 10th, 6.9. So we need to decide if we have a Pythagorean triple. Are all of the side lengths whole numbers? They're not. Because we had 8, 4, and 6.9. It's not a Pythagorean triple. You're going to do number 3 by yourself. If your calculator doesn't have a radical, just let me know and I'll bring you a calculator for a second. Alright, what's the hypotenuse here? X. So that means you got 15 squared plus 20 squared equals x squared. 15 squared is 225. 200 squared, 220 squared is 400. Add them together, you get 625. Take square root. So our missing side length is 25. Is this a Pythagorean triple? Yes. Alright, so what was the most common Pythagorean triple again? 3, 4, 5. So I want you to take a look at the one we just did. What are each of these side lengths divisible by? 5. 15 divided by 5 is 3. 20 divided by 5 is 25 divided by 5 is 5. So 3, 4, 5, and multiples of 3, 4, 5 are the most common Pythagorean triple. So that's a yes. We'll do our word problem on below. From school, you biked 1.2 miles due south and then a half mile due east to your house. So let's draw that. What is my starting point? That's school. I started at school, and then I biked 1.2 miles south. So where do I go for that? Down. And 1.2 miles. All right, and then I go a half mile due east to my house. So where is east? To the right. And I end up at my house. I went south, then I went east. So the reason this pertains to anything we are doing is, remember, never eat soggy waffles, okay? North and south and east and west are perpendicular to each other. So when we stop going south, even though I didn't draw a great line, when we stop going south and we start going east, that is a right angle. Okay, because north and south and east and west are perpendicular to each other. Okay, so what it's asking, if you had biked home on the street that runs diagonal from your school to your house, how many fewer miles would you have biked? So how many, let's talk about this. How many did we bike in general? How much? We biked 1.7 miles. Good, because we went 1.2 and then 0.5. We need to figure out what we would have biked if we would have biked the diagonal. Do we know the length of the diagonal? No. Can we find the length of the diagonal? Yes. What can we use to find the length of the diagonal? A squared plus b squared equals c squared. Good, the Pythagorean Theorem. All right, what are my a and b? 1.2 and 0.5. And then I don't know my hypotenuse. I don't know the diagonal. 1.2 squared is 1.44. 0.5 squared, 0.25. That equals x squared. Add them together. What's 1.44 plus 0.25? 1.69. Get x by itself. What do I need to do? Take the square root. So x equals 1.3. So the length of the diagonal road that I could have taken was 1.3 miles. So what should I do to find out how many fewer miles I would have biked? I'm going to subtract. Okay, I biked 1.7. I could have biked 1.3. So the difference is 0.4 miles. At this point, you're not going to turn to page 2. You're actually just going to flip the whole paper over onto the blank back. What I'm going to have you write are these 3, because I'm going to teach you how to do them without a calculator. And I'll tell you the reason. So you're going to write the square root of 5 squared. And the next one, and the next one. Did you write all 3? Okay. So in this next section that you're going to learn, we're going to use the Pythagorean Theorem to decide if we have a right triangle. So in order to do that, we're going to take side lengths and be plugging them into the Pythagorean Theorem. So when you do that and there's a radical, number 1, you just need to know how to operate a radical. But also number 2, whenever you are allowed a scientific calculator next week, in the middle of the week, you need to know how to actually plug it in, because there's a correct way, Javon, and then there's a wrong way. Okay? So, square root of 5 squared. If you need to stand, please stand in the back. But I do not want to see your eyelids. Yes, ma'am? Sorry. I say that to my daughter. I apologize. Thank you, Javon. All right, so we got the square root of 5 squared. So if you remember, sorry, I didn't mean to erase my triangle up there. If you remember, we had our equation, we had like 18,225 equals x squared. How did we get rid of the squared? We did the square root. Why did we do the square root? Because that's what you do. Because they're opposites of each other. They cancel each other out. It's like when you have 3x equals 15. What do we do to get x by itself? We divide by 3 because 3 is multiplying times x. So to get rid of multiplying times 3, you divide by 3, and that cancels it out. So when you have squares, the opposite of a square is a radical. They cancel each other out. So on this first question, you have the square root of 5 squared. They cancel each other out. So all that's left is 5. That's it. Square root of 5 squared is 5. The long way to say it, what's happening when you're squaring something? You're not doing half of it. You're multiplying it times self, right? So this is the same thing as the square root of 5 times the square root of 5, which you keep the radical. What's 5 times 5? 25. What is the square root of 25? It's 5. So any radical, it doesn't matter how big the number is. If you had the square root of 1,000 and you squared it, guess what the answer is? It's 1,000. Okay, so squares and square roots, they cancel each other out. So let's look at the difference between the next two questions. They're very similar, but one is correct and one of them is not. Okay, if you had a triangle, so I'll draw it again, apparently. If you had a right triangle and one of the side lengths was 2 square root of 3, and I wanted to plug it into a squared plus b squared equals c squared, you would want to make sure the whole thing is being squared. So which of these is written correctly? If I want to represent the whole thing as being squared, the one with the parentheses. So if you want to put a star next to it, again, at some point next week, you're going to be using a scientific calculator. Every single year, someone says, Mrs. Marshall, I plugged it in, my calculator gave me the wrong answer. Your calculator is a machine and it's not wrong. It's you, boo-boo. Okay, so make sure you put parentheses so it knows the whole thing is being squared. Because what's being squared in the second example? Just the square root. Okay, so let's talk about how to solve this without a calculator. Super simple. If you have 2x, what is the 2 doing to the x? It's multiplying. So when you have 2 square root of 3, it's multiplying. They're not the same. They're not the same term. They're not like terms. So this is 2 square root of 3 is as simplified as it gets. It's like 2x. You can't simplify 2x anymore. It's just 2x. So what we do when we square it, you want to square both parts. So what I do is I split them. Okay, I didn't change any value. I just split them with a multiplication sign between them. And I'm going to square both of them. Okay, I just distributed the square, if you will. Okay, so I split them with the 2 times square root of 3, and I'm squaring both pieces. What is 2 squared? 4. And what is the square root of 3 squared? 3. Remember that the square root and the square, they cancel each other out. So all you have is 3. So what is 4 times 3? 12. Whereas in the second example, we already said that the square root of 3 is the only thing being squared. There's no parentheses. So the 2, nothing's happening there. What's the square root of 3 squared? 3. And 2 times 3 is 6. So parentheses, they matter. Okay? I follow this math teacher on TikTok, and she had this shirt that around the holidays, like Christmas time. And it said this, and it had like a cute little, I don't know, it was designed whatever. But it said ho raised to 3. So what do you think that it's wanting to say? Christmas time? Yes. What does Santa say? Ho, ho, ho. However, what is the only thing being raised to a 3? The O. So there's 3 O's. So that doesn't spell ho, ho, ho. So to have ho, 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 you would need parentheses. Then it would be ho, ho, ho. See what I'm saying? It's something that students will struggle with even in Algebra 2. Like, what's being squared in this? 2x squared. What's being squared? Just the x. So a lot of students think that everything's being squared, but without parentheses, it's just the thing that's closest to it. Come on, I'm not saying your name again. Go to page 2. This is the last thing we do together for today. We're going to tell whether the triangle is a right triangle. We use the Pythagorean Theorem. If a squared plus b squared equals c squared, then we have a right triangle. So, when we do this, we need to identify what would be the hypotenuse, what would be c, if this were a right triangle. So, which of the sides would be the longest? Yeah. So, think of the square root of 100 is 10. So, the square root of 113 is 10 point something. So, our hypotenuse is the square root of 113 squared. You can put parentheses if you want, but there's no number in front of the radical. So, you don't technically need them, but if you want them, you can. It more so matters on, like, this one over here where there's a 4 in front. Okay. All right, so A and B are 8 and 7. What is 8 squared? 64. 7 squared. And the square root of 113 squared. 113. What is 64 plus 49? 113. So 113 equals 113. Do we think this is a right triangle? Yes, because a squared plus b squared equals c squared. So we're going to write that it's a right triangle. We're not just going to write yes, because I would like for you to be in the habit. Tomorrow we're going to learn about identifying acute and obtuse triangles using the Pythagorean Theorem. So just write a right triangle. All right, letter B, same idea. A squared plus b squared equals c squared. What would be the hypotenuse here? Yeah, 4 times the square root of 9. You can also tell it's just, this would be the possible right angle. These two aren't right. So when you write 4 square root of 95, you need to have those parentheses to signify you are squaring the whole side length. All right, plug in A and B. What is A squared? Sorry, 36 squared. 1,296. And then 15 squared is 225. We're going to do the 4 square root of 95 off to the side. I'm going to do it off the side at least. So I haven't done anything yet, I just rewrote it. Remember, I'm going to separate them with a multiplication symbol. And then I'm going to distribute the square, if you want to call it that. So both of them are being squared. All right, 4 squared. 4 times 4? 16. And then the square root of 95 squared. 95. 16 times 95 is 1,520. All right, so then 1,296 plus 225 is 1,521. So do they equal? They do not. So this is not a right triangle. So normally I would teach you the bottom portion, but I need to do your supply check. Tomorrow, basically what's going to happen is we use the Pythagorean Theorem to decide if a triangle is acute, right, or obtuse. So we would use the same theorem, plug in the side lengths, and then this bottom is the only thing that's going to change. We would look at this and decide if we had an acute triangle, a right triangle, or obtuse. If it was a right triangle, they would equal. If it is acute, the hypotenuse squared would be smaller. So which one of these numbers represents the hypotenuse squared? The right side, right? The c squared. So if the hypotenuse squared is smaller, it is acute. If the hypotenuse squared is larger, it is obtuse. So in this case, what kind of triangle would we have? It is acute, because 1,520 is smaller than 1,521. So this would be acute. That is the last thing from the section that we learned. Okay? What we're going to do now is I'm going to hand out the worksheet. You're going to get started on it.